As I promised regarding the exam review sessions, this is our second session for derivatives, and today my focus will be on problems from University of California, Berkeley. And you can see the first problem is a fraction form function in which we have cosecant x as the denominator and x2 plus x plus 1 as the denominator. And we have to use the quotient rule for this function. And the quotient rule says we have to take the derivative of the top times the bottom function as it is minus the derivative of the bottom part times the top over the bottom function in power of 2. Let's do it. So for here we have dfx dx equals, for the top part and the derivative of the top part, we would have minus cotangent x times cosecant x, and this is going to be multiplied with the bottom part, which is x2 plus x plus 1. And for the second term we have to take the derivative of the bottom part first, which is 2x plus 1 times cosecant x over x2 plus x plus 1 squared. So this is the final answer. Using the quotient rule, we obtain the derivative of cosecant x over x2 plus x plus 1, which was an exam problem from University of California, Berkeley in 2002. Let's look at the second problem. For the second problem, as you can see, we have multiplication of three functions, which are x, e to the power of x, and s square root of x plus 1. And basically we have to use the product rule for this whole function, and I'm assuming that x times e to the power of x is basically our first function, and s square root of x plus 1 is our second function. And let's say this is hx and this is gx, and we have to use the product rule when we are multiplying two functions. And therefore dfx over dx will be, for the first term, which is hx, the derivative is going to be e to the power of x plus x e to the power of x, and we have to keep the second function as it is, which is s square root of x plus 1. And now if we look at the second term, which is s square root of x plus 1, we have to take the derivative of that term now. So it's going to be 1 over 2 x minus 1 over 2 times the first term, which is x times e to the power of x. Easily, with using the product rule, we obtain the derivative of this function. Let's look at the third problem. When we look at the third problem, the first thing comes to mind is the chain rule. And when we are dealing with the chain rule, we have an inside function and an outside function. And for here, the inside function is cos x to the power of a, and the outside function is the whole function to the power of b. So we can assume that this cos x to the power of a is basically u, and it's going to be u to the power of b. So the first thing we have to use in here is going to be the power rule for the outside function. So let's look at the derivative. So it's going to be dfx over dx equals to, and using the power rule for the outside function would give us b times cos x to the power of a, and the whole cos x to the power of a is going to be to the power of b minus 1. And now it's time to look at the inside function, and the inside function is cos x to the power of a. So the inside function is cos x to the power of a. Again, here we have to use the chain rule, basically because we have an inside and outside function. So the inside function for this one is the outside function is cos, and the inside function is x to the power of a. And in order to take the derivative of this, we have to take the derivative of outside function first and then multiply it with the derivative of inside function. And the answer is going to be minus sine x to the power of a, which is the derivative of outside function, and we'll keep the inside function as it is, times the derivative of the inside function, which is x to the power of a, and the derivative of x to the power of a is going to be a times x to the power of a minus 1. So this is going to be a x to the power of a minus 1. Basically, in this problem, we have used the chain rule 2 times. First, we used it for the whole function and assume that cos x to the power of a is u, and then after taking the derivative of outside function, we looked at inside function and we noticed that we have to use the chain rule again, and then again we use the inside and outside rule, and we obtain the derivative of the whole function. Thank you for watching this video. If you enjoyed watching this video and learned how to take the derivatives of different functions, please subscribe our channel.